Hi, my name is Marius and I am very happy that you decided to join me. Introduction to Networking for Complete Beginners. You can ask, why did you decide to record this series? When you check my training, you can find General Networking, MTA, Windows Servers, MTA in Networking, CCNA, a lot of courses dedicated to networking for beginners. I decided to record a really short course. If you do not feel comfortable going for instance, MTA in networking, you feel that, well, even though it's for beginners, I still don't feel I am ready. I have seen that before. People want to be comfortable. If you want to study a new subject, a new topic, it is a good idea to have some knowledge, to know some basics. And that's what I wanted to do, to make you feel more comfortable. If you want to join, for instance, my General Networking, MTA, Network Fundamentals, MTA Service, CCNA, and so on, make you feel better and more comfortable. It will be much easier for you to understand all topics, because here, it is like we have 7 subjects, sections that I decided to cover, and it's really for beginners. For instance, we talk about basic commands like ipconfig, traceroute, and ping. And of course, when we get to MTA or CCNA, I talk about these commands, I show them to you, but still it is like, oh yeah, I've seen it before. Oh yeah, I remember ping. Yeah. And of course, I talk a little more. I, for instance, introduce NS lookup command, things like that. It makes your life much easier. It is much easier for you to join General Networking, MTA, even though they're still for beginners. Thank you very much, and I hope you're going to enjoy this series. Introduction to Networking. Why do we need networks? In this lecture, we're going to talk about networks in general. I'll show you what a server is, what a firewall is, routers, switches, a lot of interesting things. Stay with me. It is pretty easy to come up with a definition. Network, it means that you have at least 2 computer systems, that they are connected, they are linked together, they can work together, they can see each other, they can talk to each other. What does it mean? It means that, for instance, if you're at home and you have a router, okay, and they are linked, okay, it means that you have a router and then you have a laptop. What else? You can have another PC, maybe a phone. What else? A printer, a tablet, a modem, a scanner, everything that you can imagine. Today you can buy a fridge that is wireless. It means that you can monitor that remotely. It's crazy. And that's what a network is. You have at least 2 systems that are linked together. They can talk to each other. They can see each other, exchange information. And thanks to that, yes, you can browse the internet, you can go to Facebook, and of course, you can access all local files and documents as well. Here is a nice diagram that I found some time ago. I like to use it because it allows me to help you identify devices and components of a network that we use today. I'm pretty sure you're okay with clients' PCs. That's pretty obvious, and we'll not talk about that. Here is something that is more interesting, a server. What is a server? I'm an infrastructure engineer, I use Microsoft, but of course it can be a Linux server. In most companies that will be a Microsoft server, Windows Server 2008, 2012. In most cases it will run something that is called Active Directory services. It means that you will have a centralized infrastructure. Everything in one place. If you know what I mean, it means files, permissions, printers, policies, everything that you can imagine will be in one place. Of course, you can have more than one server. The idea is the same, that you have a place. For instance, imagine that this PC wants to access a file on that server, and it is my favorite name when I teach. It's Mike and John, so let's use Mike. Mike wants to access a file on a server. You go to the server and say, okay, Mike is allowed to do this or that. I will add him in most cases to a group. It means that Mike became a member of, let's say, HR group 5 minutes ago. It is a good thing because groups are flexible. Why? Maybe next week your manager says, well, Mike, he stopped working at our HR department and he was moved to sales. Make sure Mike is not allowed to access these files anymore. And you don't have to go to 25 places and say, okay, well, what about this file? What about that printer? What about this area? What about that database? You don't have to do that because you have a group. It means that you have to remove Mike from that group, and that's it. I want to stop here because we do not have time to talk about servers and Microsoft infrastructure. If you're interested, I think the best place to start is MTA servers. Okay, it is a really nice certificate from Microsoft that you can get and learn, well, basics, fundamentals of Microsoft servers. Of course, I cannot leave it like that. I have to show you a real server that is Windows Server 2012. Here you can see a nice dashboard, Server Manager. It's new, it's different. If you think about Windows Server 2008 and 2003, it is better. It allows you to identify any issues straight away. Let's try and identify some network devices. Yes, we have a firewall and a router. A firewall is a device that in most cases is responsible for your security and the security of your network. A router in a small office, home office network. In most cases, it is an edge device that is connected to the internet. Yes, thanks to that guy, you can browse the internet, and please note it is a wireless router. And you all go, okay, I don't have any devices like that in my network, and it's still a network. Yes, it is. If you're at home, in 99% you will have a firewall and a router in one box. It's one device. It's okay. A lot of even companies do that. What about the server? You don't really need a server. Some people go for a NAS server. Okay? A storage server. It means you can have cloud solutions. You can have a service like Dropbox in your own network. You can make backups, manage IP cameras. It is a really powerful device that you can run in your network. That's where I want to stop. In our next lecture, I will show you a firewall, and the router will talk about network devices in our networks. Thank you very much. Hi guys. Thanks again for joining. I hope you will enjoy the course. Believe it or not, but it takes a few months to create a course for you. I will really appreciate if you take 1 minute and rate this course. Please remember that I am here if you have any questions. Enjoy! Introduction to networking. What is a network? Part 2. In this lecture, we're going to talk about firewalls and routers. Just to remind you, here is our simple network diagram, and we are after this guy, this firewall over here. It is designed to make our network secure. I have a Cisco ASA firewall. We'll talk about Cisco devices later on. For now, I just want to connect to that device, Cisco ASA 5505. It is again a small office, home office device. It means it's cheap, easy to manage, not powerful, and good enough if you have 25 users in your network. Let's check it out. Here we go, I am connected. First of all, please note I have my inside and outside interface. And you all go, what does it mean? Inside means that is my inside network, my network. It means that I can expect devices like printers, computers, scanners, phones to be over there. Outside, it is an interface that is connected in most cases to the internet. Okay, yes, thanks to that we can browse the internet, we can go to Facebook and post a message. Oh, I saw a really awesome course delivered by Marius, check it out. Thanks to this outside interface, your device can be connected to the internet. An ASA firewall is a really powerful device that allows you to enable a lot of interesting features. We do not have time, and it's beyond our discussion to cover things like, okay, how can I enable this or that? I just want to introduce firewalls and show you what's available. First of all, please note there is a section called routing, and you say, okay, what does it mean? It means that this firewall is a router. It means it can route, it can send packets, it can make decisions. Shall I go this way, that way? That's what I said. In a small office, home office network, you can expect to have an all-in-one device. And that's what that's what Cisco decided to do. They created a device for a small office. Now, please note, of course, there is a firewall. We have VPN, virtual private networks. It means we can work from home in a secure way. The last section is dedicated to device management. It means you can create users and tweak settings that you need. I hope it makes more sense now when you think about a firewall. You can create a lot of interesting policies on a firewall. You can decide Mike is not allowed to browse the internet. This printer should not be available for HR departments and so on. A lot of things that you can enable on a small box like a firewall. That's what I said. A lot of firewalls, to be honest, most firewalls that you can find today, they have a router on board as well. That's why they can be edge devices. They can be connected to the internet directly. Let me say it again. It means that you can combine these two features, make it, create one box here, connected to the internet directly. In our next lecture, we're going to talk a little more about Cisco. I'll show you an ASA 5505, a picture of a firewall like that. We'll talk about Cisco certificates. Stay with me. Thank you very much. Introduction to networking. Network commands that you need. I decided to cover 3 commands: ipconfig, ping, and traceroute. You have to know them. Make sure that you play with these commands. They're available on Windows XP, Windows 7, 8, Windows 7. It doesn't really matter. You will find these commands everywhere. Make sure that you're okay, you know how to use them. To access these commands, we go to Start and we type CMD. Thanks to that, we can access a nice black screen. We can type commands here. I want to keep the commands on the screen as well so you can see them. Let's start with ipconfig. We type ipconfig and press enter. It is enough to produce a really nice output that summarizes TCP/IP settings. It means we can see our IP address, subnet mask, default gateway, and a lot of things that you need to know about your local network. I'm pretty sure you know what an IP address is. It allows you to identify a device. It is like an ID number, okay, or a postcode. It is very specific. It has to be unique in your network. Thanks to that, computers and network devices, they can talk to each other. A subnet mask, I will leave it for now because we have a session dedicated to subnetting. We'll talk about that later on. What is a default gateway? Do you know? In most cases, it is a router, an edge device that allows you to browse the internet. The way it works is, if your PC says, I have no idea how to get to facebook.com, it's not in my network, then if a PC is confused, if it doesn't know, it says, well, I will send it to my default gateway. There is a chance that this guy knows how to get to facebook.com. It's not guaranteed. However, I don't know what to do. I will just go over there. In most cases, it is a router, and a router can help me, can take me to, of course, our favorite website, cisco.com, facebook.com. You have a lot of switches available for all these commands. What you can do, you can type ipconfig ? You will see all switches that are available for you. I want to show you this one, all. It's really important because you will see more. You will see your DNS, DHCP settings, a lot of important things. What I want to show you is DNS. What is DNS? Domain Name Server. It allows your PC to translate a name into an IP address. It means google.com into an IP address like 5.7.1.7. DHCP is a special server that can give out lease IP addresses. That's where I want to leave because it is beyond our discussion to talk about services like DHCP, DNS. For now, please memorize and understand that DNS allows you to translate a name to IP address. DHCP will give out lease IP addresses. That was ipconfig. Let's check ping. Ping is a very simple command that allows you to check if a host is alive. It means I will ask, mate, are you alive? Can you reply, please? You can ping an IP address or a name. Let's say I want to ping google.co.uk. And google.co.uk says, yes, I am alive, if you're interested. Of course, if you know, you can ping an IP address directly. An example is 8888. You know what that is? The most popular IP address in the world, Google DNS server. If you know, you can ping an IP address directly. Why is it important to know that command? We'll talk about troubleshooting later on. Please note, request timed out. It means that one message was not delivered. Okay, something went wrong. Of course, you can press the up arrow. In most cases, it's a one-time thing, and we're okay with that. It can happen. You can imagine a lot of traffic on the internet, and of course, our message is not the only one. That's why it can happen. What you can do with ping, you can keep pinging by using a T switch. Thanks to that, you can leave it even for hours and check if a connection is stable. Traceroute is a command that allows you to see the route taken by a packet. It means you can see all, how we call hops, all routers to the destination. As you can imagine, let's say you go to google.com. Of course, you will go through 20, 25, 37, whatever number of routers, internet service providers. When you use Traceroute, it can help you identify an issue. I have CMD open. We type Traceroute. In Windows, it's trace-rt. And then you specify again an IP address or a host. One switch that you have to use, it is D. If you don't use it, Windows will try and figure out what the name of an IP address is, and it takes forever. That's why you should always follow it and add D. Then let's say I want to go to google.com. Oops, if I spell it. Now it is going to show you all hops, all routers, all internet service providers that are on their way to google.com. Sometimes you will see request timed out. It doesn't mean that there is a problem with that message. Sometimes it means there is a firewall. Firewalls don't like traceroutes, and in many cases they don't report themselves, and that's why you can see requests timed out, even though there is a connection, there is a router, there is a way to get to google.com, you will see requests timed out. I let it finish. Please note trace complete. Our next lecture, Cisco. Thank you very much. Introduction to networking, Cisco. Introduction to the world of Cisco. It's very difficult for me to talk about Cisco in a course like that because it takes years to learn Cisco devices, management, and so on. I will try and give you a very good idea about Cisco certificates, devices, things that you need to know if you want to start your career in IT. Maybe you want to learn a little more about networking. Cisco certificates are really important. If you want to get a job in IT, even if it's a support role, you should get that certificate. CCNA. It's really, really important to get that, guys. It's really important. A lot of companies, they ask for CCNA. That is something that they require, even if you work with servers, because it proves that you know a lot about networks. It's not only how, Cisco will of course teach you how you can manage a Cisco router switch. Still, they will show you a lot of concepts and things that you need to understand. Thanks to that, when you get an HP switch, that's absolutely fine to set it up. If you're CCNA certified, it should not be a big problem for you. Then, in a couple of years, if you're good enough, you can go to CCNP, the professional level, and then CCIE, something that is very difficult to achieve. How can you start? There are 3 points I want to show you. First of all, build your own lab. In my CCNA Real World series, I discussed that in details. It's really important. If you want to work with Cisco, you have to have a lab. You have to have a real network. That's the easiest way to learn. Buy a couple of Cisco devices. It is so cheap to do that on eBay. Play with them. That is point number 2. Break and fix. The easiest way to learn is to break something, then you have to fix it. I have a rack at home, okay? A real rack at home with, 15 different devices. And you can say, well, you are crazy. Yeah, I am. However, it allows me to learn a lot because it's my real network. If something goes wrong, I have to fix it. You want to see my rack? I'll show it to you. Here we go. Cisco switch to HP servers. Then a couple of firewalls, Cisco ASA 5505 and CyberRoam, 2 core switches, 2 HP switches, a backup firewall, and a VMware server. Point number 3, get a job. We have a dedicated lecture to that point. That's why I'm not going to discuss anything in details. I'm pretty sure you know what I mean. You have to find a job. You cannot lab everything. It's very difficult to simulate all issues. And it's, I can argue it's impossible. That's why experience is so important. We'll talk about that when we get to that section. In our next lecture, we'll talk about Cisco hardware. I'll show you a couple of Cisco devices. Stay with me. Thank you very much. Introduction to Networking, Cisco Part 2. I'll show you a couple of Cisco devices. Here we go, a very, very popular Cisco router, 887VA. Now I showed you an ASA firewall, ASA 5505, that's the box over here. It's cute, isn't it? At the back, again, it is a small office, home office device. That's why there is a switch. It means you can connect devices. One thing that I want to mention, it is a PoE device, Power over Ethernet. It means that you can connect, for instance, a voice over IP phone and you don't need a power cord to it. These 2 ports can deliver power. Of course, you have to buy a device that is compatible with that standard. Here is a lab that I use to teach Cisco. Please note there is ASA 5505, there is an access point. It's a clip from my CCNA real world labs. Here is an access point from Cisco 1131, a very popular access point. It means you can connect to a device like that using a wireless card. There is a very similar router 881, Cisco ASA 3, 4 switches to be more specific, and a few routers. In this lecture we talked about Cisco. If you're interested, I encourage you to look at CCNA, CCENT. You will learn a lot about Cisco, how to manage a device like that. If you're interested in security, it is CCNA security. You will learn about firewalls and security protocols. In our next lecture, yes, subnetting. Thank you very much. Introduction to networking. Subnetting. We are going to talk about IP addresses, subnet masks. I want to make sure that you have a very good idea where to start. We'll have 2 lectures dedicated to that topic. I want to start with IP addresses and subnet masks. Make sure that you understand. I decided to include that in this series, even though it's pretty advanced when you think about that. Subnetting is not difficult. You just need some time to figure it out, to think it through. That's why I like to introduce that straight away, because it gives you more time to understand, to play with it, to watch it again. Later on, it is pretty easy to move to more advanced topics. If I can give you that advice, subnetting is not difficult if you take your time. Make sure that you master all basic examples. You're okay with subnet masks, with private IP addresses, everything that we're going to cover in the next 10 minutes. Make sure that you understand every single word. Later on, it will be, believe me, very easy to move to more advanced topics. Let's get started. Ready? What is a subnet and a subnet mask? You can think of a subnet as a piece of your network. And a subnet mask is something that allows you to answer the following question. Am I on the same network as that printer, as a server, as a router? It is a really important question. Let me give you the following example. There are 2 PCs, PC1 and PC2. They're connected to a switch. And this switch is connected to a router. That's how we draw a router. Let's say router, switch. And of course here, access to the internet. PC1 wants to send a message to PC2. And at the same time, or a second later, PC2 decided to go to Facebook. Yes, let's post some updates. If PC1 and PC2 are on the same subnet, they will talk to each other like that, directly. If PC1, yeah? If PC1 is not on the same subnet as Facebook, and of course Facebook is somewhere else, it is over here somewhere, then PC1 will send it where? To its default gateway. Because PC1 says, well, I have no idea where Facebook.com is. It is not in my network. I will send it to my router, because this router should know how to route, how to send that message to Facebook.com. It's time to answer the main question. How will that happen? Not sure if you've seen a subnet mask before. Example is 255.255.255.0. And for now, to keep it simple, please memorize that 255 means match on network and 0 means I do not care. I don't care. Now, 2 IP addresses. Just, the easiest is the way to understand is to try it out and show an example. 192.168.1.25, an IP address, and 192.168.1.179. Are they on the same subnet? Now, 255 means match. 192.192. Yeah, it's okay. 255. Yeah. The third octet, that's how we call it. 1, yeah, that makes sense. And 0, I don't care. They do not have to match. It means, yes, they are on the same subnet. What if I added 192.168.8.71? Now, we know the first 3 octets have to match. 192.168, and then it's 8. That's not good. They don't match. This IP address is not on the same subnet as the first 2 IP addresses. Now let's check the table that I prepared for you over here. We talk about IPv4 because there is IPv6, and in IPv6 the subnet mask is not as important in many cases, but it's beyond our discussion. Our main focus is on something that we use every day, which is IPv4. We have 5 classes of IP addresses. If you decide to go for, let's say, CCNA, MTA in networking, CompTIA, whatever, you will have to memorize these ranges because you can get a question like that on your exam. Please note it's, you have to memorize the table. Class A starts with 1 and the last IP address is 126. That's it. There is nothing to understand. You just have to memorize these 5 rows. That's it. One thing I want to mention is that every single group has they have a default subnet mask, and this is something you have to memorize as well. Class A, B, and C over here. A, B, and C. Now one more example to make sure you're okay with everything. Let's say I have 10.10.7.25, 10.10.8.129. Can you give me a subnet mask that will make them available on the same subnet? So I want them to be on the same subnet. Can you go for a subnet mask that will make it happen? I hope that you said, well, I can go for class A or class B. Both will work. Class C is not good because the third octet is not the same. It's 7 and 8. That's why it's not good to go for 255.255.255. It's okay to go for 255.0.0.0. Even though they match, I said I didn't care. I'm okay. I don't really care. They match, they don't match. I do not care. That's why this subnet mask is okay. And of course, 255.255.0.0, because the first 2 octets, they have to match. That's where I want to stop. We'll continue our discussion in the next lecture. Thank you very much. Introduction to Networking, Subnetting Part 2. I will start with one example to make sure that you're okay with subnet masks. If not, please make sure you watch my previous video. 10.10.11.25, 10.10.11.79, subnet mask 255.255.255.0. Are they on the same subnet? The answer is yes, because the first 3 octets have to match. That's an octet, right? 255.255.255.0. I hope it's okay. If not, please make sure you watch my previous video. What is this subnetting all about? You can get a lot of questions. One of them, let me give you an example. 192.168.1.0, and they asked you, can you be so nice and divide that IP address into 5 sub-networks? What does it mean? It means that we do not have enough IP addresses. We do not really need 254 IP addresses, because that's what we have available over here, because with this IP address and the default subnet mask 192.168.1.0, the last IP address is 192.168.1.255. We are not allowed to use the first, we are not allowed to use the last IP addresses. The first IP address is called the network address, and this one is broadcast. Broadcast, it means send everywhere. If I don't know where, I'll send it everywhere. You're not allowed to use 0 to 55. That's why the first IP address is .1 and the last usable is 254. That's why we have 254 IP addresses. What you can get is we don't really need 254 IP addresses. However, we need like 5 subnets and around 25 IP addresses for each subnet. For security reasons, for many other reasons, you will not get 5 ranges. What I mean by that, they could just give you 192.168.1.0, 192.168.2.0, 3, 4, and 5.0. Okay, 5 different ranges. It's, but you just need 25 IP addresses and there are 254. You can say, wow, that's a lot, mate. It's not. There are some companies with, thousands of users in one building. It's not enough. And for security reasons, if you want to create a policy, a firewall rule, you don't want to have 500 subnets and networks. You don't want that. That's why a question might be, you need 5 networks. Now, how do you do that? We'll not go through the whole example because that is far beyond our discussion. That is introduction to networking. I want to give you a very good idea where to start. If you're interested, if you go for CCNA or MTA in networking, you will learn everything in details. The idea is that we will play with our subnet mask. Do you remember? 255.255.255.0. Now, do you remember what I said? The first 3 octets, they have to match. It's for your network. And if they have to match, you're not allowed to touch them. You're not allowed to play with these octets. It means you can do something in the last one. And what you're going to do, you're going to take some bits, because it's in binary, and you will say, well, I will use them for my network. And of course, you will not end up having 254 hosts per network. You will get like, let's say, 16, 32, 64, and so on, because it's again in binary. So you can't be very specific. You can't say, I want to have 25 hosts per network. It's in binary. Of course, there are some other ways you can achieve things like that. Anyway, this is the way it works. You take your original subnet mask and you play with it. You take this octet, cause 0, and do you remember 0? I don't care. It's for my host. It means I can make that happen. I can take the last octet and divide that into 5, 7, or 500. Or here it's not possible. It would be possible with 00 into sub networks. I hope it makes sense. It's introduction to networking. That's more than enough for now. If you're interested, MTA in networking, you can learn more. Thank you very much. In our next lecture, how to get a job in IT. Introduction to networking. How to get a job in IT. I have 10 minutes to tell you how you can get a job in IT. It is not going to be an easy task. I will try my best, give you some tips and where you can start. Let's start with that table because it is something I like to show to, in a way, encourage people, and it is a good idea to show your salary. It's not bad, isn't it? It all depends where you want to work. Our training is dedicated to networking. That's why we are interested in roles like system engineers, system administrators, maybe software engineer. Project manager should have a very good idea about networking. Database admin, yeah, why not? You know how much you can earn now? How can I achieve that? There are 3 main things that you have to focus on. The most important one is experience. The second one is certificates. Then it is a good idea to have a degree, especially if it's going to be your first job in IT. Experience. It's always tricky because you say, I want to find a job in IT. How can I find a job if I don't have any experience? How can I gain any experience if I can't find a job? We go back to our discussion, make your own lab, create a network at home. That's, I spent like 20 hours recording, I recorded more than 20 hours of videos dedicated to Cisco real world labs, where I, show how you can play with your network, fix, break, see what happens if I press this or that. Of course, it will not replace a real world scenario. It will not. However, in my opinion, it is a very important point. It will allow you to learn a lot. When you get to an IT, to an interview, when they decide to, let's say, send you an email and say, okay, can you pop in and we can have a chat? This is something you can bring up. You can say, yes, I did this or that. Even if you say it was in my lab, in my network. For instance, you can say, well, I have a Cisco ASA as my edge firewall. If I used to be an IT manager, and if I heard anything like that, I would be pretty impressed, because it's not crazy difficult to set it up. However, you have to know what you're doing. It's not, with all due respect, it's not a Linksys router. You have to know something about Cisco if you have an ASA running at home. Of course, there is a chance that you asked a friend. Still, it's pretty easy to figure it out. That's why I do not lie, because I can ask one question and I'll figure it out. Is it a good idea to work in IT? Oh yes, it is. It all depends what you want to do. This training is dedicated to networking. That's why you can work as a network engineer. You can be a project manager. You can be a team leader, an IT manager for a network team. Networking is really important. Even if you're going to be a software engineer, there is a big chance you will have to understand what a subnet mask is, because maybe you're going to design a piece of software that will use some protocols, and then you will have to study even CCNA to code an application that a client asked for. In our next lecture, we'll try and fix a few issues in our network. Thank you very much. How to fix a home network, a small office, home office network. It's not an easy task. However, we have covered a lot of interesting things. I encourage you to watch the second lecture, the second section, network commands that you need, because we will need them. That is like, you have to know ping, ipconfig. I will add 2 or 3 more commands, and I show you how you can fix a network. Every time you start troubleshooting, it is a good idea to follow a method, something that will help you identify an issue and sort it out. You all go, well, but it's like a home network. What do you want? Do you want me to create a plan and implement? And the answer is yes. You don't have to do that on a piece of paper. I want you to think like that. Okay? I want you to think like that. I want to make you aware of things that you can miss if you don't follow a procedure like that. For instance, you receive a phone call from your client or from your friend, and he says, well, my laptop is dead, I don't know, just take it away, I don't really care. You're not going to say, well, let's replace the system board. And just, what? No, what are you going to say? Well, you have to define the problem and get more information. What do you mean it's dead? The screen is dead. If you press the power button, nothing happens. What's wrong with it? It's just, it's not working. That's what, end users say. Or the internet is slow. What does it mean the internet is slow? Want to see an example? Stay with me. Thank you very much. Introduction to networking, how to fix a small office, home office network, part 2. The internet is down, what shall I do? That is our scenario for this lecture. Do you remember? Point number 1, let's define the problem. The internet is down. We need more information. What does it mean the internet is down? You can't go to Facebook, or you try and send an email. What does it mean the internet is down? I can't browse the internet. Maybe it's a local issue. Maybe it's an issue with a server, with your internet service provider, with a website, with an email server. There are a lot of things that you have to think of, and that's why you need more information. To keep it simple here, we know that the internet is down. We can't browse, we can't print, we can't browse, we can't send any emails. We have tested it on 5 different PCs so far. We know the server is okay. That's it. That's all we know. I want to use the CMD. That's why I want to use that example. What I like to do is, of course, do ipconfig, make sure that I'm on the right subnet. That is my IP address, that is my default gateway. it is a good idea to go one hop at the time. What I mean by that is, you can imagine that you're over here. This is your router that goes to another router, and, you know. And then you go to facebook.com. This is your router. You paid $25 for it. It's an awesome, cheap router. You're connected to it. Okay? It is a good idea to go one hop at a time. Can I get to that guy? What about this one? What about that one? What if I go down here and instead of Facebook, I will access something else? Okay? We are over here. We're creating a plan. Now, we're going to implement that. Let's give it a go. So we want to go one hop at the time. We'll ping our default gateway, 192.168.1.1. It is a good idea to make sure it is stable. That's why you can use remember? The switches, T, you can keep pinging. Leave it for 1 minute, make sure it's stable. Time is 1 millisecond. That's what you should expect because it's your local network. You don't have to go anywhere. In most cases, you're even directly connected. That's why it should be fast. If you see like 500 milliseconds, that's not good. Please remember, if you use wireless, then it can be much slower. Still, you should not see anything like 300 milliseconds. We're good here. Now, how can I figure out what my next hop IP address is? If you're lucky, you can use traceroute. Do you remember? And let's say google.co.uk. If you're lucky, you will see, here we go. That's the first hop, that's the second hop IP address. That is the default gateway for your router. Your router is going to send that message to another router, and the IP address is over here. You can highlight, right click and copy that. Let's ping it. Again, T. Please note, 1 millisecond, stable. Do you understand? Yeah, then it can be more difficult because you can have a firewall and so on, but what have we found so far? That is point number 4. What have we found so far? We know that we can ping our router and we can ping our ISP, Internet Service Provider, because that is our ISP. It means that in most cases, the issue is beyond our ISP. I hope it makes sense. It will help you troubleshoot networks. I want to give you one more example related to wireless because there are a lot of things that can go wrong, with wireless. We'll talk about that in our next lecture. Wireless troubleshooting. Stay with me. Introduction to networking. Let's troubleshoot some wireless issues. I want to show you one application that you should download straight away and check your wireless networks around you. It's Insider. Just Google it. You will find it without any problems. There is a licensed version. There is a free version. You can see if you need a license for some additional features. Here I want to show you what you can use this application for. The main problem with wireless is it's not reliable. And what you can see is that you can have a lot of wireless networks around you. If they use the same channel, you will have a lot of problems. That's why it makes sense to use an application like that. It will scan your area, okay, around, in this case, a laptop, it will produce a nice graph. Please note, that is my network, MKM, and I can see the channels that are available, that are in use. That is my wireless. You go to wireless and wireless settings. In here, what you can do, you can go for a channel. Auto means I will try and figure out what the best channel is. However, what they don't tell you is that on some access points, well, it's really hard coded. They do not scan the frequency. So I do not trust a setting like that, an option like that on simple routers. It is a good idea to go for channel 1, for instance, in my case. Then you click save. In most cases, it is somewhere under wireless settings, channel, and you can decide what you want to use. It's not easy to troubleshoot wireless. I hope that you will download Insider, play with it. In our next lecture, we're going to talk about your next steps. What can I do next? Thank you very much. Now I have a pretty advanced lecture for you, but do not worry, it's not to show you how to configure a feature that I've got over here. No, it is to encourage you, to show you how amazing it is to go for this career, how cool it is to configure a firewall, a switch, and so on. So here I have a really cool lecture for you. I have an ASA firewall. You've seen this firewall already. And this is a brand new firewall from Cisco 5506. And this firewall has a really unique feature. It has something that is called a firepower service. It means that you can really filter and block whatever you want. It means that you can block, for instance, a website, a service, or even an application. And this is what I want to show you. I have ASA open, and well, we're going to block Firefox. So I have Firefox open. Now let me refresh. I can access the internet, as you can see, and now I will configure my firewall and block Firefox. So over here I have a special rule. Again, it's not really designed, this lecture, to show you how to configure what is this. No, it's just to give you a very good idea what you can achieve if you decide to go for a more advanced path and certificate. Over here we have applications, and here I just want to show you how amazing it is, how many things you can really block. So please note, I have Firefox on the list, but there are applications that you know very well. Let's say, what can we block? Let's see if there's Outlook. Do you know Outlook? Yeah, from Microsoft. Yeah, so I can block Outlook, an application that allows you to download your emails. Yeah. What else? Of course, Internet Explorer. Just we're talking about applications that can access the internet, and the same applies to URLs. You can be very specific what you want to block, and there are a lot of predefined sections, as you can see. And with just one click, you can say, for instance, okay, search engines. Okay, you're done. Google, Yahoo, and so on. It's really cool. So we have this policy in place. Now we have to apply it because it was disabled. Now we need to apply it and then test it. I will pause the video and come back to you when it's done. I will open Firefox again and we'll test it. Okay, as you can see, policy is up to date on this device. It means that we can open Firefox again and we'll see how it goes. Here we go. As you can see, it's loading. It says waiting for cisco.com. I can't access any websites using Firefox anymore. How cool is that? Just to make sure I can access the internet, the same website using Internet Explorer. As you can see, no problem. Yeah, how cool is that? You don't have to know anything about servers, ports. No, you just say, okay, I want to block Firefox. I don't want my users to access search engines, look for a job, and so on. Again, my goal was not to show you in details how to configure this policy. It was to encourage you to learn more, and I hope that you're going to become a network engineer and come back to me in a couple of years saying, oh, thank you, Marius, it was really cool. Now I can deploy all these things by myself. It's time to say goodbye. Introduction to networking. I always wanted to record something like that, because even if you think about my training general networking, you can say, well, it's the same. It's not, because general networking, we talk about routers, switches, firewalls. I have a lot of labs in it, and it's pretty advanced when you think about some points, and it's like 6 hours of videos. You need time, you have to lab. Here it's like, okay, I have no idea about networking, or I have not touched a router for 5 years. I want to learn something about that in 90 minutes, in 2 hours. That's what I wanted to achieve, and I hope that you enjoyed this series. Thank you very much. Hi, a D-Link IP camera. I'm going to deploy an IP camera, and I decided to show it to you. It is a D-Link wireless camera that I bought a couple of days ago. And yeah, here we go. I will try and connect it to the network, set it up, see how it works. I hope you will enjoy it. And again, I encourage you to buy an IP camera, play with it. It's really, really fun. Okay, this camera is connected to the network. There is a quick installation guide. It says there are 2 ways that D-Link suggests. First, you can use WPS. I'm pretty sure you know. Don't use it, it's not secure. Yeah, we'll not do it. Then they say you can use a CD and just run an application. It's really strange because they do not give you like a standard option for people who know what they're doing. It's like, okay, you can connect to the network, it will get an IP address, and I hope I will be able to access it. It's really strange that they don't give you this piece of information. Well, we'll try and do it. I have an IP scanner, Angry IP scanner. My DHCP range starts with 100, and let's scan to 120. We have to find this IP camera. Laptop, PC. Okay. So maybe it's 103. Let's check. Here we go. Okay. Let's try admin and password. No. Admin. No. 1, 2, 3, 4, 5. No. 1, 2, 3, 4. No. Okay, I will have to check what the default username and password is. Okay, I found it online. Here we go. There is no password. Okay, fair enough. Just press OK. Easy. Okay, we can access it. Let's wait, see what happens. It can add. Here we go. It can add a piece of software. Come on. Not a good start, to be honest. Let's try this one. Here we go. Here we go. It can still complain, oh, it's not up to date. I have some Cisco devices, this is why I keep an old version of Java. But, okay. Here we go. Okay. Cool. Seems to be working. And we didn't use a CD or online application, just an IP address. Yeah, that's me. I'll show you a few options. So let's go to setup. Of course, you can use wireless. It is a wireless IP camera. You can set up dynamic DNS. Let's go to motion detection. I'll show you how it works here. Then you specify an area. Let's say you're interested in these 3 areas. And you can save settings. Then you can decide what to do with it. What I like about D-Link cameras is that you can say, send me a message immediately. It is a good thing. A lot of cheap IP cameras will wait and take like 3 photos and email it to you. It is useless because someone can just grab this IP camera and smash it. So it makes sense to take this option. Of course, you can specify your email account and send an email. You can upload your files to an FTP server. Day-night mode, just standard options. Let's go for wireless. Here you can enable wireless. It will scan your SSIDs. It will just show you a list of SSIDs. Yeah. It is not an HD camera, so it is only 640480. Thank you very much. Network Attached Storage Device, NAS. The idea is very simple. We need a central place that we can use to make a backup, to upload and access our files. The easiest way is to deploy something that is called a Network Attached Storage Device, NAS. I will not lie to you. My favorite device is from Synology. I've been using these devices for, I think, 10 years now. It should not be a surprise for you that I have a brand new device, but this time I want to show you how you can configure it. We will open the box and install it. Before we move on, it is worth mentioning that a NAS device is available as a tower device, something that I've got over here. You put it on your desk or in a small comms room. My device supports up to 2 disks, but a tower NAS device can support 2, 4, 8, 12 or even 16 disks. It's a different story if you want to take it to the next level. Let's say you have a big company or even a data center. You want to buy something that is called a rack-mounted device. You have a special rack, you install your NAS device over there. Okay, enough talking, let's open the box now. What's inside? A pretty small unit, a quick installation guide, and some cables. We have a network cable, actually 2, and the power supply unit. How does it work? At the back, we have two local area network ports. A USB port, we can connect an additional USB drive, power, and a security slot. What's that? You want to make sure that this device is in a way secured. This is a small box. It's very easy for anyone to grab it and take it away from your desk, from your shelf, and so on. We need something that will secure this device. The easiest way is to use a special lock, a cable lock, Kensington. It is a very popular solution for a laptop as well. Going back to our device. When we open it, we will see two slots for two hard drives. You can install up to 2 disks. A really unique feature of this device is that it is a toolless device. Believe it or not, but you don't need a screwdriver to install hard disks. That's the idea. Everything can be done without a screwdriver. I will show you how it works. When you check this tray, you remove these two plastic pieces. They will keep your hard disk in place. Come on, focus, focus. Here we go. You can see there is a hole that should be aligned. We put it all back together. Slide it in. And that's it. We repeat this process for the second slot, for the second disk. You can ask, why do we have 2 disks in place? In most cases, in most scenarios, you want to have a backup of this backup. I know it sounds crazy, but that's the idea. In most cases, you will configure your device in a way that even though you have 2 hard disks, one will be a backup of the primary disk. Of course, you can just configure and use both disks. It is up to you. In most scenarios, this is what you're going to do. When you're ready, you put it all back together, power up, wait a few minutes. How can you access it? This is a wired device. You grab a network cable and connect it to a switch or a router. After a minute, you type find Synology.com. Come on, come on. Synology, I believe in you, come on. Here we go. Awesome. Connect. We will see a very basic wizard. This is the easiest way to get started. Sure, let's set it up. DSM is the brain behind our NAS. It's the operating system of a Synology NAS device. We want to install it. We will see a warning, yeah. We will remove all data from your hard disks. That's okay, brand new disks. We have to provide a server name, username, password. A really interesting thing is that for security reasons, yes, we shouldn't use admin, but take a look. When you say administrator, well, it's allowed. I would not allow both, but to be fair, admin is a more popular word. The idea is you should not use admin. Quick Connect is a way to access your device using the internet, but you don't need to change anything on your router. This is based on something that is called dynamic DNS. You don't have to know a lot about this solution, just create an account and give it a go. That's it. Our NAS is ready. If you're interested, please stay with me. Let me know. I will record more lectures and show you how to use this device, how to create folders, share files, and enable really cool features. I really want to keep all my courses up to date. It's not only that I want to add random lectures, I want to show you cool devices with unique features. You know, I am a big fan of IP cameras. I've been using them for years. I've been using D-Link IP cameras, and when I saw this guy, I said, I have to show this camera, I have to test it, I want to see how it works. Is there anything special about this IP camera? Yes, there is. There is one really cool feature, auto motion tracking. Your IP camera can follow whatever is in your room. So I said, you know what? It sounds like a really good idea to put my puppy to a test. Before we get to that point, I have to show you what you can expect. In the box you can find the IP camera, just a power cord and some paperwork. The idea is that you have to use your phone. There is no way to manage this camera using a web browser. I know some people say, well, I wish it was possible, but today everything is just, installed on your mobile phone, and the same applies to the latest D-Link IP cameras. You cannot really control them using your PC, your Mac. You have to use your phone and a dedicated app. The idea is that you download it, create an account, and then you scan a special code, provide a PIN, there is a label on this IP camera, and you're ready to go. It literally took me like 2 or 3 minutes to install it. Very easy, no questions asked. You can ask, okay, how can I store my pictures, movies, and so on? There are 3 main options that you can go for. The first one is you can store everything using your mobile phone. When you start recording, everything will be saved to your mobile phone. There is a slot for an SD card. The third option is something that is called D-Link Cloud. So you can actually upload everything to the cloud. There is a free plan, and of course, if you need more space, if you want to keep your videos for a longer period of time, you have to pay some money. So a lot of options if you want to record and keep your videos. Of course, there is motion detection, day and night features, just a lot of pretty obvious things. But I was really interested in this cool option, auto motion tracking. As I said, I put my puppy to a test. Here is the clip that shows how the camera reacted and how my dog reacted. Take a look. Believe it or not, but when I was done, my puppy wanted to play with this camera for a few hours. It was really fun to watch. To summarize, I was very happy with it. This new feature, a pretty unique feature, auto motion tracking, worked very well, and that's why I wanted to test it. I wanted to see this new feature. Well, it seems to me it's really cool to use. Network security, virtual private networks. In this video we are going to talk about VPNs, virtual private networks in general. We will try and define a VPN, why we should start using a VPN connection, and we'll try and answer a question: is it secure? The first question is, what is a VPN? We can say that a VPN, a virtual private network, is a network technology that allows us to set up a secure connection over a public network. For instance, the internet. That's the easiest definition I can come up with. As you can see on the screen, we have 2 sides. one in United States, one in Taiwan. What we want to do, we want to send a message from PC1 to a server that is in the USA. The problem is that this is the internet. We know the internet is not secure. What do we mean by that? Well, we will go through, 50 or 60 ISPs, internet service providers. Anyone can, in theory, look at your message. And that's not what you want. You want to make sure that PC1 can download or send a message, doesn't matter, to or from this server in a secure way. What we mean by that is we want to make sure that nobody can look at our message, or to be more specific, cannot figure out what's inside, because we can't really do that. Just, your ISP, internet service provider, can in theory always look at your messages. The idea is to encrypt your traffic. We are going to talk about it later on. I don't want to get into details at this stage. We'll have a dedicated video or even two to encryption. Again, a virtual private network allows us to create a secure connection over a public network. That's the most common definition you can hear and see. We have two main types of VPNs. You will find that on the internet everywhere. People try and, group VPN connections. There are many different ways of doing that. I want to talk about two main types. It's a site-to-site VPN and a remote VPN connection. The first one is site-to-site VPN. This one, it is over here, and that's what we saw in the previous picture as well. It means we have two sites, two networks, two locations. We want to send a message from this network, from this site, to the other side in a secure way. To make it happen, we need a VPN connection that will be established between these two sites, not between these two PCs, in most cases between these two sites, using a dedicated device. It can be a router, it can be a firewall, it can be a VPN server. In most cases you will have a dedicated device. This PC over here, as far as this PC is concerned, it has no idea it's going through the VPN. Absolutely no idea. It thinks that, well, this PC is somewhere on my network, whatever, I don't really care. I can reach that PC. That is a site-to-site VPN. Sometimes you will hear people call it LAN to LAN. Or I think Microsoft like to call it router to router VPN. That is not a very popular term. Site to site VPN, LAN to LAN VPN. What we mean by that, this is LAN, local area network. Let's call it LAN 1. And this is local area network 2. We are going to connect these two sites, again, these two sites. We are going to connect them using VPN, but we are going through the internet. It's not a secure place. We don't trust people on the internet. That's why we need a site-to-site VPN. The second type of VPNs is a remote VPN. It is over here. And in this case, we are at home. What we want to do, we want to connect to a server that is over here. It can be our workplace, or let's say that is our office, whatever, or maybe you're in a hotel and you want to connect to your home network. This is a remote VPN connection. You have a laptop, you have a PC, you have a mobile phone, you want to VPN to this network. That's how we call it, to VPN. We can use that as a verb as well. We can VPN to this network. What it means is we are going to set up a secure connection, but this time between our laptop and our VPN device. Again, it can be a router, it can be a firewall, it can be a dedicated server with a piece of software running on it. It doesn't matter at this stage. The idea is that you are going to set up a tunnel, a VPN tunnel, a secure connection that will allow you to connect to these guys. And the last thing I want to discuss at this stage here with this slide is that when you VPN to this network, you will have this feeling that you are over here. That's the idea of VPNs in most cases. You will feel that you're actually connected to your main network. It feels like you were in the office. That's the idea. Of course, sometimes what you want to do, you want to tell that, well, sorry, if you VPN, you will not be allowed to access this server. I don't know, for some security reasons. I don't know. It can happen. It's not a very common solution, because if you can VPN, then you should get access to things that you use every day. Still, it can be achieved using, for instance, access list policies and so on. Again, site-to-site VPN and remote VPNs. We have a lot of VPN protocols, and we are going to discuss them later on. Now I want to mention that there are protocols that were designed to make VPN work. Yeah, we need something that will allow us to create this site-to-site VPN or a remote VPN tunnel, and we use dedicated protocols to make it work. As you can see on the screen, I listed 4, in my opinion, the most popular protocols. There are some other protocols, or you can group them again in many different ways. PPTP, L2TP, IPsec, and SSL. The first two, again, I will not get into details because we'll cover that later on. PPTP and L2TP, they are really popular because there is a client built into Windows. You don't need to download anything. That's easy. PPTP is not secure anymore. We should avoid using it. IPsec is really a standard for VPNs today. If possible, we should use IPsec and avoid using especially PPTP. L2TP can be combined with IPsec. SSL is a new flavor of VPN, if you wish, and I noticed that people have deployed a lot of SSL VPNs in the last couple of years. It has become really popular. I'm pretty sure you all go, okay, what is SSL VPN? It's like, just, what's that? Again, we'll have a dedicated video to SSL VPNs. The idea for an SSL VPN is to make your life easier and allow your users to connect to your network using a web browser. It means that they will open Firefox, Chrome, Internet Explorer, whatever browser they want. they will type an IP address or a name, let's say company.com/SSL, whatever name you dedicated to that service, and they can connect to the network. Awesome. You don't need a client, you don't have to set up anything. No, in a way, you browse the internet. And that's what your users love, because it is simple. As you probably know, all users know how to browse the internet, right? That's what they do. They go to Facebook, YouTube, whatever, Twitter. When you try and teach them how to use PPTP or let's say Cisco IPsec client, they say, that's really complicated, mate. When every time I show someone an SSL VPN option, they go, wow, that's it? Really? I just put my username and password. It's like going to Facebook, mate. Yes, it is very easy. You open a web browser, you can access your corporate network. Again, there will be a dedicated video to SSL, and we will discuss that in details, and I'm going to show you an SSL VPN, probably on an ASA Cisco firewall. Is it secure? Well, it all depends if you have set it up in the right way so far, and make sure that you go for the best protocol possible with the best options possible. We'll talk about encryption, authentication, options available for your VPNs, and what is the best available. However, sometimes it is not that easy. There is a chance that your device will not support IPsec VPNs, something that you should use. For instance, if you want to let's say you have a home network, yeah? You are a home user. Let me just show you what I mean. Let's say you are over here. That's the internet. That is your home router. Let's say, I don't know, Linksys. And this is your network. Let's say you have a server here, a NAS server, a very popular device that you want to access. Of course, there are many other ways available for you to access it. I will focus on VPN here. You want to VPN to your network, right? What's the problem? Well, the problem is that you will have to check if your device supports VPNs at all. There is a big chance it's not an option. If you bought a router for, I don't know, £40, do not expect any VPN options on it. At all. Do not expect that. You have to pay much more to have PPTP. That's the basic VPN. Not sure if you remember, we discussed that a few minutes ago. If you want to have something better like SSL, do you remember, the web browser based VPN, or IPsec? Well, that is £100. Of course, there is a way around. We can use OpenVPN. We can use, for instance, for Linksys routers, we can use an alternative firmware image. Still, if you want to go for VPNs, you will have to invest some money. That's the only way to make it happen. Of course, there are options that I prepared a lab for you, TeamViewer. There are some free options available for you, but believe me, if you want to use that every day and it is a serious project and you want to have a reliable connection, you will go for a piece of hardware. You will have a dedicated router, a dedicated firewall or a dedicated server, a Microsoft server, a Linux server, if you know how to use it, you will have a dedicated device that will be responsible for connecting for your VPNs. In this video, we talked about virtual private networks in general. We discussed VPNs. I answered the question, why should I start using a VPN? And we mentioned a few things about the security aspects of VPNs. Thank you very much.